Astronomy Part 9, Telescopes. How have telescopes advanced since Galileo?
So a lot of people think that Galileo invented the telescope. He didn't actually quite invent it, but he did perfect it quite a bit. So telescopes kind of came from looking glasses that people would use, especially in military, battles and stuff like that, to see where the enemy was or whatever. And this was eventually then kind of, turned up into the sky. And Galileo was the first person to take two lenses in a telescope, and that's why he made them so much better. And the big advances kind of came in when we started using mirrors instead of lenses, because mirrors are much more stable and stuff, and lenses it's like hard to make like a really big lens, but you can make a big mirror a lot easier than that.
So lenses made of glass. What are mirrors made out of?
Mirrors are made out of just like a surface, and then they coat it with something reflective like mercury or something like that. And mirrors can do the same thing that the lenses do. They just focus light onto a point. And so bigger telescopes are always better. We kind of kept making bigger and bigger telescopes, and we get better mountings and stuff, things that can track an object for a longer time and do so more accurately. That's a big deal. And now today we have these like 8-meter telescopes like Gemini, and we have telescopes in space like the Hubble Space Telescope.
Now, when you say 8-meter, that's the diameter of the reflecting lens?
That's the diameter of the biggest mirror.
Got it, in it. So 8-meter, I'm speaking American, so that'd be about 3.3 times, so about 28 feet. Is that right?
Real big.
Real big. So I gotta believe that instead of looking from ground level of Earth through miles of atmosphere with smog and particles and water and everything else that all distorts the image, that when you have a telescope already resonant in space that doesn't have to look at that, it's massively more effective, right? And it also doesn't have lots of tweaking that happens because it's not rotating at many hundreds of miles an hour as well. So is Hubble the state of the art for what we have for that kind of telescope today, and it's just pointing itself at different parts of the universe and mapping our past, or?
Well, as of right now, Hubble's doing pretty good. We're going to put the James Webb Space Telescope into space in like 5 or 10 years or something like that. We do have a huge advantage in being in space in that we don't have this atmospheric distortion. The biggest problem with the atmosphere is turbulence. You get turbulence in the atmosphere, and it kind of like takes these point-like stars and spreads them out into this kind of like messy blob type thing. So being outside of the atmosphere really helps in that way. The downside of having to put things out in space is that it's really expensive to put heavy things out in space, so we're really limited in terms of size. So some of the other like really big ground-based telescopes coming up, there's telescopes called like the TMT, which is the 30-meter telescope. You can imagine this thing is 30 meters, I mean, like 100 feet. You can't put that in space. So there's a big trade-off in that way, and the biggest ones give you the largest field of view and the best resolution. But if you're out in space, then you don't have this distortion. So it really depends on what exact kind of science you're trying to do.
And as I understand, when you're actually filming astronomical observations, you're collecting light over a period of time, meaning there's a mechanical set of tools that tracks the actual object in space. As the Earth is spinning, it stays anchored on that object, and the lens continues to collect light for hours at a time in a given night, so that you can see very faint objects or objects that you can see. You have better color separation and so on. How does that process work? Do we still use like film, or is that electronically done? Is it a CCD, like a chip device and a camera?
Yeah, so we do use CCDs, like you were just saying, like, not that much different than what you have in an iPhone or something like that. And this is much more efficient at collecting light than any kind of film or an old Polaroid camera or something, or your eye would be. And we can basically store up this light before for a long time until we read it out and can actually look at the image. But as I was saying earlier, the importance of being able to track an object accurately, that's actually a big challenge in instrumentation. And so now having these very accurate telescopes that can point and track an object for a very long time, then we can get these very deep, what we call like a very deep exposure.
How did Galileo improve the telescope? What are the advantages of using mirrors in a telescope? What are the differences between telescopes on Earth and those in space? On what medium do modern telescopes record?